Hi, everybody. Welcome to EthStaker Community Call number 43. Today we have Puffer Finance joining us. Puffer is a permissionless, is a protocol where node operators can operate permissionlessly. So we're super excited to host and see how node operators can get involved and participate and get into the specifics, the weeds of how Puffer, the protocol, works. So today I want to introduce EthStaker first. We have Remy from EthStaker, Hanny from EthStaker, and we have Jonathan Meyer, who's a community member. We have Lottie Slaus, who's also a community member. Jonathan is actually going to be hosting this call. I will pass it over to him in 1 second, but first I want to mention that we have more community calls coming up in the following weeks. Which you can look at ethstaker.cc/events. You can go look at those. And if there are more topics that you want to cover, if there are more protocols that you want to see covered, please bring it to the EthStaker Discord, and we would love to host more calls. As I am transitioning out of EthStaker, we want to make sure that we have a lot of calls coming up and make sure that we transition quite well. So I'll pass it over to Jonathan to introduce the Puffer team and the rest of the agenda.
Great. Thanks, Nixo. Yeah, hi, I'm Jonathan. And we have Jason from Puffer on the call today. And Jason Vranek is the CTO of Puffer Labs. So Jason, we're really excited to have you and, learning about what Puffer is, how it works, get into some specific questions and anything around governance. So yeah, we'll kind of go through it all. I guess I wanted to just start off with like you telling us a little bit more about your role at Puffer and how you got involved and yeah, just like give us a brief overview in that sense.
Yeah, of course. Thanks so much for having me here, by the way. Super excited. So the background kind of with Puffer and me was my co-founder Amir and I were friends back in the day in college. And kind of after sort of later on in our career, we kind of rejoined together and found crypto, I guess. My research background in grad school was around building out like ZK hardware accelerators and trying to like make proving kind of more viable, cheaper, things like that. And throughout that career, I kind of transitioned to these trusted execution environments, which became like a core piece of the tech stack kind of later on in Puffer. But I ended up teaming up with Amir, and we were focusing first on building like an off-chain compute platform, kind of these co-processor things that we're seeing today, using like off-chain TEEs to do these big computations. But later on, we teamed up with Justin Drake, and we were trying to first implement his liquid solo validating research paper, which was how you can build a completely permissionless liquid staking protocol by leveraging these TEEs. And like fast forward, like it was a great foundation, but we realized like you still can't build that until Pectra is out. So we had to do a lot of modifications over the past 2 years.
And sorry, TEE, just for like the acronym, can you just clarify what that is?
Yeah, TEE is a trusted execution environment.
Okay, so that's what you're referring to. Okay.
Yeah.
Cool. Okay. So yeah, if there's more about the override, I didn't interrupt you exactly there. But yeah, like so if there's in terms of like connecting to ETH staking, like I think I understand like at a base level that, it's a way of staking, but also it involves eigenlayer, it involves restaking. Can you talk about a little bit of that architecture and kind of getting a little bit deeper into how it functions and how, for maybe somebody who's familiar with more vanilla staking on Ethereum options, how does this kind of take it another step further?
Yeah, absolutely. So maybe I'll dive into a little of the history of the architecture because it's definitely changed a bit. So this started towards the end of 2022, like pre-Shanghai. Justin was starting to get worried about like the dominance of Lido, and was trying to help us like build a permissionless alternative, like Rocket Pool, but trying to adopt these like TEEs as a piece of the tech stack. And so there was kind of a lot of lot of different design iterations that we'd gone through. We were dabbling a bit with DVT as well as like one of the building blocks here, but really ended up settling like on this TEE design. And there were a lot of like mechanisms that we had to add, and I can kind of probably go into more detail on those later. But like the TLDR was that we managed to bring down like the capital requirement, like the bond requirement to run a validator significantly. But and that was like our goal was like, okay, make the bond lower in a safe way, and then like decentralization. But I think it was a lot more complicated than that. One of the concerns was you needed like to really have better profit margins and justify some of the hardware costs. We were just predicting that people would be stacking multiple validators on the same piece of hardware. And then we've now reintroduced all of the capital requirements that we'd sought to reduce. So that really led us towards EigenLayer. We were trying to look for additional revenue opportunities for the validators. Like, and a lot of this was motivated because we'd originally started trying to build out that like off-chain compute platform and was struggling to find this product market fit. And that's where we realized like, well, if we had a base layer of validators that were kind of always online, always generating revenue, then we can start to allow them to do this job on the side. And like conveniently, that was exactly what EigenLayer was building. And so that's when we started to try and adopt or like modify the LS or liquid staking protocol that we're building and into the restaking protocol today.
Okay.
Actually, Jason, could you like just expand upon that and maybe give an overview of just like how Puffer works? Like as I'm a permissionless node, I'm a node operator. I want to get involved in the permissionless node operation part. How does that work? Like, am I necessarily participating in EigenLayer? Like, what is the minimum? You said you lower the capital requirements. What is the lower capital requirement?
Yeah, absolutely. So maybe it's easier before like adding all of the restaking side to just describe this as a liquid staking protocol. Because you could kind of think of them as like we're just sandwiching on top of the restaking part. But so to run a validator today, it's 2 ETH is the requirement as a bond. And we have like a lot of plans on our version 2 upcoming to like reduce that further, but maybe I'll save that for later. So you put down 2 ETH and you also pay these things called validator tickets. So this was one of those mechanisms that we had added, and this was to try and get around like 2 issues. One was, I mean, I don't think rightfully so, but a lot of people have criticized like Rocket Pool for just being like the hobbyist validators, not like the professional P2Ps, etc. And like that being kind of a FUD point. And so validator tickets are a way to decouple the performance of operators from the actual yield that the like LST or LRT holders are earning. And the idea is like straightforward. Hopefully, I think this is always the hardest to explain. So you would essentially pay upfront some discounted amount. Like if you're expected to make, let's just say $10 per day running a validator, you would pay the protocol, say $9. And that's $9 immediately rewards the stakers, like the LST holders. And then in exchange, you get the rights to like run the validator for 1 day. And you would get to keep all of the consensus layer and execution layer rewards. And so that's like, would be like the 10% kind of profit margin. So now you can see how like a validator could be offline, not generating any rewards, but the LST holders are happy. There's some issues, I guess, with that. Or
yeah. I was going to ask. So if you, as a node operator, do have bad performance, such as you're offline or whatever it may be, does that mean you lose money since you're paying for rewards up front, but not getting it back through performance?
Right. Yeah, this was like in a way to incentivize for people to kind of be online, and because at the end of the day, like you're still borrowing the capital from the like LST holders.
I like it. So
Uh,
your own bad performance is only affecting your own income.
Correct. And there's like some complications there around like MEV, which I can talk to, and I think is one of the bigger UX problems that we have today, which we're addressing in like V2. That's more about like predictability of rewards. But maybe just to finish on like the mechanism itself, there was like the other point that we were trying to resolve was like we were day one, our objective was like, what are the safe ways that we can reduce the bond requirement? And like, of course, you have to account for slashing risk, but the other thing that you're adding to the equation as bond goes lower is like this rug pooling concept. So it's like what Justin calls it. That's the idea of if I get a MEV payout that is worth like more than my bond, I'm incentivized to go and steal it rather than to like send it back to the pool and send it back to essentially the stakers who put most of the capital up front. So that is like, I still don't think there's a way to solve that like in protocol or out of protocol really. Like we had so many designs around like having to police this activity and slash people after the fact and so many complications, and you don't really know at the end of the day if like the MEV that's reported on chain is the true amount or if there's some off-chain deals happening. So the idea here is that the validator ticket price is including some small amount of like daily MEV revenue. So like if you go and propose a block and it's like that 100 ETH block, you just get to pocket it all. Like it's all yours basically. I can talk to some of the problems though, some that we've been facing around this is on the MEV side. So, and I think MEV is just always the problem plaguing all of Ethereum, and like what are the mitigations to solve it? In this case, because you're paying into like daily, some like expected daily value of your MEV, like you're not proposing a block every day. So that means like until you propose your block, you're starting to kind of operate at a loss, and then you get that big spiky payout. And like that's why we like things like MEV smoothing. It's like it's more consistent. But for that reason, like it's a little difficult for validators like to predict ahead of time what their exact income is going to be, given that they have no idea when the block proposal is coming.
Wait, so if I'm a Puffer node operator, I am or I am not participating in MEV smoothing?
So yeah, today not.
Okay, so given that like people only get proposals on average, like I think 5 to 6 months, every 5 to 6 months at this point, does that mean that operating as a Puffer node operator is possibly not profitable until that time?
Right. That's the concern is you kind of have to wait for those proposal opportunities. And so kind of the time horizon for profitability expands. And of course, like if you're running, like you have the capacity to run many validators, like you can smoothen this out for yourself, but that's like not really what we're building this for. So yeah, we're trying to address this in the next iteration of the protocol.
And what's the plan for adjusting that?
Yeah, so the plan there is this other topic that's kind of was introduced into the ETH research community kind of towards the end of last year, and this is called a tester proposer separation. And the big idea there is that like MEV is this inevitable thing. I don't think we can really get rid of it, but it sort of has those economies of scale where it will centralize whatever it's touching. And the important part is that we're keeping the validator or like the attestations are decentralized. And so the idea of, with the tester proposer separation, as the name kind of implies, is to essentially create two separate roles in the Ethereum consensus protocol. So your average person would be an attester. You would put down your 32 ETH and handle like voting on things on chain. And then like the proposers can go and kind of centralize and do their thing over there. And ideally we have like lots of censorship resistant gadgets in place. So in that world, like if you're just focusing on attestations, there's no economies of scale because your validator or the consensus layer rewards are just a function of how many validators are on the network. So it's deterministic.
I want to ask this question maybe here about like eigenlayer and how just like understanding more about how that's involved. You know, like vanilla stakers, I think a lot of us maybe are like not sure how to like think of it, or just like it's new, and so there's not like trust built with how to like think of participating with that. So is there added risk with eigenlayer being involved? Is it like how do you think of that, and what would you recommend?
Yeah, I'd say there's like a whole spectrum of risk we're talking about. Like, of course, the first one is smart contract risk. Is of course like you're just adding another protocol on top of this. And I think another one that hopefully now is just completely removed, but during like the last iteration of Eigenlayer's contracts, it was pretty expensive for you to actually get your rewards out, consensus layer rewards, because they you have to submit these proofs on chain, and it kind of, I think some of the bad estimates were like around 30 to 40% of your consensus layer rewards were burned in gas. So I'd say that is a risk, but I think now that the new upgrade is like much better about that. And then in terms of like beyond that, I would say it's all kind of opt-in. Like at your own discretion, you get to decide to join these AVSs. And it should just be like, I mean, of course, there's like, again, risk on the AVS side from like the operations point of view. Like, I think one concern is always what happens if like an AVS just decides to upgrade their contracts or introduce arbitrary slashing conditions. This is where like the Eigenlayer protocol has their own safety nets here, where they have like this veto committee on slashing in case something like that were to happen. But beyond that, it should all be this endogenous risk. So if I join AVS number 1 over here, like it's kind of on me if I slash, because like I'm fully in control of my keys.
Just to clarify some points, if I am a node operator and I want to participate in Puffer, what is my withdrawal address and what is my execution layer rewards address?
Okay, good question. So your withdrawal address will be one of these eigenpod contracts.
Wait, sorry.
Yeah.
But if you're a Puffer node operator, you don't necessarily have to participate in Eigenlayer. Did I understand that right?
No, so yeah, today in Puffer, like you are by default a natively restaked validator. So you are going through Eigenlayer.
I see. Okay. So withdrawal address. So you necessarily are participating in Eigenlayer, but you are not necessarily participating in like in opting into certain AVSs. Is that correct?
Right. And so right now, like maybe just in terms of like risk management, so I'll kind of go through maybe the whole flow with Puffer, like as a validator, kind of combining Eigenlayer now. So you'd come in, you'd bring your 2 ETH bond, and you also have your validator tickets. There's like a minimum amount that you deposit just to avoid like griefing attacks here where people are constantly like entering and exiting. So your validator is created within one of these eigenpods, and you kind of fully control the validator at that point. But the ETH within these eigenpods is all restaked and then delegated to this kind of second layer of operators, which we just call like restaking node operators. And so from the point of view of like the validator, you're not actually participating in any of these AVSs directly. Like that is kind of delegated away from you. So no extra costs or hardware requirements or anything, but you should get this extra like boost in your rewards because like the ETH is restaked. And of course, like that comes with no rewards come without risk, and the risk is that like that restaked ETH is slashed by one of these ABSs.
I'm a little confused where the optional part is then.
So in which part or which option?
So you said it's opt-in. I distinctly heard the word opt-in
Oh,
somewhere in the eigenlayer
right, sorry.
rewards.
I was talking generally for eigenlayer and ABSs, it's all opt-in. So you would choose the risk. And in this case, like for B1 of Puffer, you kind of are opting into this eigenlayer system. So that's, yeah, not optional.
Oh, the opt-in part is using Puffer.
Yes.
Okay. Okay. So I guess one of the questions that I have is that there is a bit of distrust by vanilla stakers in participating in eigenlayer in general, just because eigenlayer adds some sublevel of systemic risk to the Ethereum ecosystem. And so I guess like the question becomes is participating in eigenlayer like is the risk worth it? Is participating in Puffer and then like opting into eigenlayer as a default, is that worth it?
I would say, yeah, definitely depends on your preferences. Like a lot of the people that we're targeting here is like, and this is like myself too, originally was in building this is I wanted to run a validator, but didn't have 32 ETH. So we're trying to like make it permissionless and accessible for those people. But if you are like very kind of distrustful of the eigenlayer system, I guess, yeah, that is maybe not for you.
Hard to overcome on that one. We have a question from the YouTube chat. Am I unmuted? Oh, it says that I'm not unmuted. Weird. What is the execution layer rewards address?
Yeah, so that is your own wallet. So that's because of the whole validator ticket process is that you get to set that to yourself. So you should be compatible with other smoothing pools.
Oh, okay. So you don't necessarily have to like be unprofitable until you get a proposal. You could subscribe to a smoothing pool and smooth out your own rewards that way.
Yeah, absolutely. So that's all external to the Puffer protocol. And like in a similar way, there's a good chunk of validators that are actually running DVT clusters on top of Puffer as well, but our protocol has no idea.
Cool. So maybe jumping into some of like a specific question here around permissionless, just permissionlessness and this will maybe get into like the governance questions too, but yeah, just like noticing that some of the geographies are blocked. Like, is that kind of, yeah, how to like treat that with permissionlessness? Like is it something, I mean, is it just like the front end that's blocked and that people can just go and interact with it? Yeah, how are you guys treating that subject?
Right, yeah, this is kind of just the result of the regulatory landscape is front end is blocked. Yeah, contracts are, I guess, do what you will.
Okay. Makes sense. And then, okay, so, and then maybe we could jump to the governance and like the DAO and like that the DAO is coming, like kind of, can you speak to like the place of that? And, you know, will that change anything about how permissioned or not it is? Like what role will it play? Could it control the entry and exit of validators? Just wanted to like understand more about how that will play a role.
Right, yeah, so I think regardless, like the protocol is always built to be permissionless for validators. And like the next steps that we're taking is to, how do we transition this, like the extra layer of the restaking operators and make them permissionless as well? And I guess the roadmap there is that, like right now we're just working with like a permission set. And then the next step once we have governance would be to allow for kind of the community to curate those operators. So kind of decided by the DAO. But the direction that we want to take this is to allow for like completely permissionless restaking as well. And so from the point of view of like the validators, we want to give them that optionality to not opt in or opt in if they want to. And if they decide to opt in, they would be the ones running the ABSs. The issue there is kind of around kind of constraints on eigenlayer. There's some efficiency issues that make it really difficult right now, and limitations on the contracts on like who's allowed to opt into what. But all of that is kind of getting addressed in future upgrades. And the other big issue was around slashing, of course. Like today, there's no slashing, but in some of the next iterations, it was always this all or nothing kind of slashing. So making that permissionless when we're talking about like the validators are controlling essentially the LRT holders capital, like that is we need to be really careful there. But we're excited about like there's lots of things you can do. Like we can add additional, I mean, you can always add more bond requirements like this economic security for the restaking operators. We're interested in like always approaching it from the technology point of view. I think maybe DVT is like a lot harder to throw in there, but adding like anti-slashers for the actual AVSs themselves. It's something we've been trying to push at the eigenlayer side, is to really standardize on the AVS signing part, so that we can have like a standardized anti-slasher for at least to cover a lot of these use cases. But the battle there is that every AVS kind of is different, and inevitably will have different slashing conditions, and like one anti-slasher can't really solve for all of that. But
Jason,
those are like the steps you can take.
Jason, I'm dumb and I don't understand restaking stuff. What's an anti-slasher in this context?
Oh, sorry. Maybe just context, like rewinding back to like Puffer's origins. So these TEE things, trusted execution environments, you can use those to build these anti-slashers. And what that means is like, it's this, I think the best analogy was always like a hardware wallet for your validator. Because today your validator signing key is always in the hot seat. If you're compromised, like they can use that to slash you. Right? Or if you run kind of duplicate node settings, like all of the footgun things that people get slashed with today. So Web3 signer, I guess probably everyone's familiar with, was like a way to do a remote signing client or sidecar, and make sure that it always keeps track of what you've signed, so that you're not like double signing. The idea with what we first built, going back now a couple of years, was this, we called it Secure Signer. It was this TEE implementation where we essentially took Web3 Signer, implemented it in this TEE, and the idea was you generate your validator keys within this, just think of it as this hardware black box. Your keys are generated within it, and by default, everything is encrypted there. And it has like pretty good kind of guarantees. We can always go down the rabbit hole of like attacks on these things, like Intel SGX is the famous of these TEs. But at the end of the day, it's this added security. So if I generated the key in this black box, and as the operator, I don't know what my key is, like it's a lot harder to shoot myself in the foot, because I can't like exfiltrate this key and put it in another validator setup and run them in parallel and get slashed. That's one part, and the other is that it maintains this slashing protection database like within this black box as well, that also helps protect you. But of course, like TEs are not like 100% bulletproof, like they've been broken in the past. But the idea here is that if you're running this kind of at home, it's like you're not, if you hack into this thing and you get your key out, you're back to like where you started, knowing what your key is.
A TEE, is that software, hardware? Does it require special hardware?
Yeah, so there's different kind of flavors of these, but the most standard is like it would require additional hardware. And Ladislas had gone and tested this out and was the first ever person to run it from their home. But of course, there was like some issues, is like additional cost. Like a lot of these consumer grade TEEs were too small to be used as a full node, kind of like a Nook. So you'd have to use it alongside. So it's just this purely additive cost. And then like go ahead.
What is it like physically, what is it? How much does it cost? And is it a big lift for somebody to have it, one of these?
I would say yes, like because or maybe Ladislaus can talk to the cost on the old one.
Yeah, so the NUC itself, there were specific NUCs back in the day when SGX were still built into them, which are outdated, right? You can't purchase consumer hardware with those hardware enclaves nowadays from Intel anymore, but it costs whatever, $200, like $150, and you could run only the signing software to validate on chain on it, and then attach sort of a node in terms of a consensus client and execution client on a separate computer. So it's essentially they started off with the idea of like let's say a ledger who has smart programming logic to it, and you can just attach it. It's put your validator key on it or generate it on it, and then just plug it into your machine. So you get rid of what Jason alluded to, a lot of potential slashing risks.
Okay, I read in your docs that if you're running one of these TEs, it's it's a lower bond requirement. It's 1 ETH instead of 2 ETH.
Right. So that was always the plan. Unfortunately, Intel has like really gone ahead with deprecating this, so we've not actually released that upgrade. Now there's like the next iteration of SGX is now TDX, and I mean, there was some exciting news this week from the Flashbots team. Like they're using this to do like private block building. So there's a lot of applications of these like popping up throughout the space now. And I think especially since around EthCC, like TEs are starting to become more of a household name and generating some buzz, which is nice because I mean, I think they're like a really great primitive to be building with and adding security to your protocols.
I guess the relevant question here is, are TEs relevant to your current system? Can node operators like participate in this, or is this totally in like a research phase? Is this something that like node operators should not be paying a whole lot of attention to? And is it not part of the current system that node operators can participate in?
Right. So for Puffer V1, the answer is like, yeah, it's not really applicable. I'd say the closest thing you get there is running DVT nodes on top. That allows you to like kind of split the bond up 4 ways and allow you to kind of run more and more validators with your friends and kind of increase the chances of MEV and those like smoothing out your rewards. But for V2, we're actually working on introducing these TEs back, or I guess the term would be enclaves is another one of these words, but usually they're just used interchangeably. So I guess you'd asked before, like are TEs hardware or software? The one that we're kind of looking at next is actually more software based, enforced at like a different level of your computer, but achieves like these same kind of properties. And what the goal that we want to go for is to allow people to like use these like anti-slashers without adding this additional hardware requirement, because people who already have their setup don't want to like go and buy more hardware here when that already constitutes like a lot of their operating costs.
Cool. That maybe is a good segue into the economics topic that we have a few questions about on that. So I guess maybe just starting us off around the APR, where the yield comes from. I noticed this statement around, that doing Puffer is able to earn, several times more than a solo validator would. Like, wanted to get more context around that and just where the APR comes from and how you would describe all that.
Yeah, totally. So, I guess this is just more of like a capital efficiency thing. Like running a validator, you're not going to earn any more than another validator, of course, but I guess in general in Puffer, you're earning like kind of the normal staking rewards plus whatever restaking rewards the protocol generates. So like some percentage of that. So that is already kind of a kind of bump up on your baseline rewards, and then I think it's mostly capital efficiency at that point. Like with 32 ETH today, you'd be able to run 16 validators on Puffer and stack those.
And are you earning a percentage of the rest of the capital that's running on your validator?
Yes, yeah. So the way
What
that's
is that? Okay.
yeah, so
Yeah.
it's yeah, you get 7.5% of like the principal. So from the 32 ETH.
And is Puffer taking a cut of that? Of the rewards that are being run on your validator?
Yeah, so 2.5% is going to the DAO, 7.5% to the validator. So I think Lido's is 5 and 5.
Interesting. So none of it goes directly to the Puffer like engineering team, like, or the Puffer team. It just goes to the DAO, and then I assume that you guys get paid out in some way by the DAO.
Hopefully, it's pretty consistent ourselves.
Okay, cool. It would make sense to keep you guys sustainable.
Maybe a quick question, which is not on the agenda. Maybe we can zoom out for a second and sort of you can give us some numbers, because we've talked to various or there are various LRTs out there, right? So Puffer is one of them, and we've sort of highlighted them by now. The differences, particularly paying upfront in terms of tickets and sort of the bond requirements and sort of some anti-slasher sort of background to the tech stack. But what are we talking here in terms of numbers? Like let's say how many node operators do you have by now? How does this compare with other LRTs? Like how much, for example, how much restaked ETH is within the Puffer protocol? Just to give us some framing here of where Puffer is inside the LRT landscape.
Yeah, good question. So just to total, like we have around 500,000 ETH in the protocol, and around, I'd say 5,000 of that, or 5,000 validators are deployed currently. And it's all permissionless, so we don't know the exact breakdown there, but I'm hoping it's like lots of diversity. That's what we're going for. And yeah, to compare that with the other LRTs, I think like the closest in size to us is Renzo has around the same number of ETH, and EtherFi is around 2 to 3 times bigger. But I think one of the big things that really was a struggle for us was trying to launch this day one as permissionless. Like I think we'd seen that a lot of like lots of promises, and it just like when you always have more and more like things to do and things to add to your protocol, it just like I feel like it's natural for everyone to just keep kicking that down the road of like, oh, we're going to make this decentralized later. So we made that like our number one priority was launch day one with permissionless and then upgrade from there. So that did delay us coming to market about 5 to 6 months after the other protocols, but luckily we were able to bounce back in time.
Now circling back to the economics bit. So to me personally, I still have a very vague picture on what AVS yield, like what Jonathan asked, like where does the yield come from? So I've understood the baseline rewards for the consensus side and the execution side, but since we have you on, maybe you can generally talk about what can we expect as stakers from the term AVS yield, and then you could maybe also yeah, put this in perspective to the risks of being a puffer node operator. Like, where are we standing right now, and maybe what to expect from EigenLayer or AVS built on EigenLayer, let's say within the next 3-6 months.
Yeah. So in terms of like the parameters in the protocol right now, the idea is you get 7.5% from like the 32 ETH capital. And then you get this kind of additional 1% kind of subsidy in a way. And this is like the AVS rewards. So that is like kind of the fee that the validators essentially are charging to the rest of the protocol. And in terms of like where that comes from, that's like from these different like operating these different AVSs. And kind of the interesting, funny part about how the whole ecosystem has played out was like EigenLayer is designed to be this very like this bootstrapping mechanism. Like you don't need your own token to bootstrap the security of your protocol. You can tap into like Ethereum security. But it turns out like everyone's going to have a token, unfortunately, and that's how a lot of these AVSs are going to be paying rewards. But not many of these actually have live tokens yet. So EigenLayer is actually going to be paying out Eigen tokens kind of as subsidies for all these different live AVSs. And so that's where most of the yield is going to be coming from, is like Eigen token emissions.
Okay, and just to clarify, so there's the AVS operation as a distinct role, like separated from the validation role of being a puffer validator, correct?
Yeah, currently, but hopefully we'll
Right.
make that like unified and permissionless as
Right,
well.
if possible. Okay, and in terms of maybe the software stack side of things, so let's say we have a listener on this call who maybe doesn't run even an Ethereum node by now, but just has whatever 2 ETH of capital and a certain amount of ETH left to purchase validator tickets, say for a year. They're interested in becoming a puffer validator, so they need to obviously get the hardware, if I understand correctly, so that like the regular hardware to be capable of running an Ethereum node. And then maybe what are the technical requirements? Is there additional software which is a puffer dedicated? Like how does the what else does a regular staker have to consider here? And maybe you can also elaborate on, is this an option for existing stakers, right, who have node infrastructure already? What would be their tasks to switch over or run a puffer validator in parallel?
Right. So I'd say for both of those people, like the hardware requirements are exactly the same and technical requirements. So just your standard validator setup. I think sort of down the line, we're going to be adding kind of one extra requirement, which is commit boost, that as the sidecar. So for like as we enter this world of proposer commitments, but I think that's still a little bit of a ways off. So for your average person that wants to run a validator, it's the exact same. I think for the people that are already running an existing validator, though, the requirement is that the withdrawal credentials are pointing to these eigenpods. So there isn't a seamless way to just like redirect it. And we don't want to ask you to like remove your solo validator to go join this, but you would be able to run the exact same setup. Like it would essentially be another key that you would add into your existing flow, but you've just deployed it through like the puffer protocol.
Do you have people in your community who are currently running alongside like a solo validator or other staking protocols? Like, what is the lift of doing this? How complicated is it to launch a puffer validator alongside what people already have running?
Yeah, so it shouldn't be much of a lift at all, but of course we're always welcome to feedback if you think like the UX and docs and everything can be improved. But yeah, I think maybe the weirdest part about this that is unfamiliar for people is this, because we have the validator ticket concept, you still need to be able to like periodically go and deposit more.
Do you, is this do you have to do this via the front end, or can you do this by CLI? Because I think most people in our community are running a solo validator with like Ubuntu server that they can access via CLI. And so is it possible to deploy a Puffer validator via the CLI alongside your solo validator?
It is possible. I think I need to like check on the docs there. I think it's just a little bit more confusing than just kind of like, but the steps are like you kind of just create. We tried to make the flow similar to the like Beacon Launchpad website. So you drag and drop this JSON file, and then you like your wallet pops up with some transactions to sign there. I think one of the like big reasons we've been kind of avoiding CLI for a lot of this, and I'm very curious your guys's feedback, is there's a lot of people that want to use like safe multi-sigs as like the owner of their like Puffer accounts, and that like is not so compatible with doing things from the CLI.
Yeah, I mean, you have these two cohorts of people. You want to onboard. We assume that most node operators, or like the biggest pool of node operators that are not currently operating a node, are going to be people who want to use it like a GUI, who aren't necessarily comfortable with the CLI, and so like that going forward maybe shouldn't be the main way that people are accessing this. But you also have this pool of node operators who you can tap into, who are currently using the CLI. And so I understand like wanting to avoid CLI, but I assume that there is a very large percentage of existing node operators who do mostly control their node with CLI at the moment. Are there
Yeah,
guides?
and
Are there docs guides on how to do that?
I'll need to check. I don't think it's as supported. And like another one of those reasons was like we would prefer not to introduce that kind of software risk where we have to like deal with key management on the CLI side. If we can instead just tap into like MetaMask or Wallet Connect.
For sure.
And to be clear, like from my understanding, if you want to become a Puffer validator, you can buy or purchase tickets, let's say for a year upfront or half a year. And the worst thing, correct me, Jason, is when you run out of tickets, your validator gets exited, and you can re-enter to become a validator the day later after having purchased another set of tickets. So it's not like that stakers need to be aware, oh, when do I run out of tickets, right? Even if they want to do it via CLI, if it's possible, but the landing page or the UI of a website sort of helps you here in any ways. That's sort of my understanding.
Right. And you don't have to use our website. Also, you could use EtherScan.
Yeah.
It is like a very simple
It's
way.
smart
A lot of
contract
people are
based,
just
correct?
depositing.
Yeah.
Okay, that makes sense. I think that most solo validators like did the transaction via the website anyway by the Launchpad, and then just maintain their validators with CLIs.
Got it.
Cool.
Switching gears here a little bit because we have about 10 minutes left. Sorry, but to the economics part, I've seen lately that Puffer is exploring based rollups and has pushed very aggressively on this term. And sort of, I'd be curious to hear from you, like now that we sort of have explored like how Puffer is, what the construction of an LIT is, and how there's yield coming from AVSs through whatever eigenlayer logic. But how do based rollups come into play? How do pre-confirmations come into play? And how does this affect validators?
Totally happy to make Puffer even more confusing for you. I think it's funny, we've seen kind of hot takes lately on Twitter, both from like the solo staking side and from like the L2 narrative side. And both of those kind of hit close to home with Puffer. So on the L2 side, this is where based rollups, I think, are a big remedy here. And so the idea is like today, rollups are sequenced by like one centralized server. There's this concept of shared sequencing where you have some kind of election protocol and you decide like who's going to be the leader to sequence potentially multiple rollups. And once you have that like shared sequencing, you're able to start giving good guarantees about interoperability. So like, let's say I'm the leader of these two rollups. Well, I kind of have control over writing to the state of each of them, and I can give this guarantee like we're going to do an atomic swap between them. That can be done in a very trusted way, and like you can use bridges to do these sorts of things. But really, if we want kind of good interoperability, we want something like shared sequencing. And so based rollups are just using base sequencing, and that's kind of, can we extend this concept all the way to the other side of the spectrum? So now, if I have a rollup, the idea, to make it a based rollup, really all I have to do is make it permissionless for people to sequence it. Just let anyone call that function on the smart contract. And at the end of the day, because each Ethereum validator really has the monopoly on proposing like the next L1 block, they have kind of the monopoly to sequence the rollup. So yeah, the concept is, and kind of the idea here is, if we want to get to this world where we have like interoperability between all the rollups and we want to get around like the fragmentation that we're seeing, we want to agree on like, we want to use shared sequencing, and we want to agree on like a neutral set of like actors to do that. And Ethereum validators make the most sense. And it already comes in with this built-in like election mechanism, which is just like consensus. So yeah, based rollup, just at a high level, is like your normal rollup just sequenced by Ethereum validators. And like this solves a lot of kind of issues that we're having in the ecosystem, but comes with this really big UX problem, is around confirmation times. So because it's slots are 12 seconds, if I'm like a L2 user, want to send my transaction to this based rollup, I still have to wait 12 seconds before I know that it's included in the rollup. And that's like very different from like your Arbitrum or Optimism sequencer, where I just send it off and I immediately get back like a success message, and I know that my transaction will be included. There's not any economic guarantee there, but I still like have a pretty good hunch that they're going to include me. So that big UX issue is addressed by these things called pre-confirmations, which is kind of another off-chain protocol, but it allows a validator to give some guarantee to the user that their transaction will be included, or potentially other stronger guarantees. And so I kind of touched on like that concept of proposer commitments earlier. Like pre-confirmations are just like one flavor of proposer commitment. And maybe to try and zoom out a bit, like how does this now relate to Puffer and LRTs? So we're big believers in based rollups in general. And so we're really trying to get one out as fast as possible. And this is in the same kind of ethos as like launching our protocol permissionlessly. There's a lot of like kind of anti-network effects here. Like it's hard to convince existing L2s to go and transition into this based rollup architecture. And there's like talks about how this is because like due to MEV trade-offs, things like that. But like economically, it's hard to convince them. And so from our perspective, it's like, okay, well, if we can't convince them, let's just build it and try and get like more of the community to join. And hopefully like the next like team that decides to build a rollup will use like a based rollup stack. So that's what we're we're working on. And now, like, so we have Puffer as an LRT, we have this based rollup, and then what we're also working on is this pre-confirmation protocol. And the way that these all kind of string together is like, so if you're a based rollup, you need someone to sequence your transactions. That's going to be from validators that have opted into this pre-confirmation protocol. And today that's built as an AVS on top of EigenLayer. And so like Puffer is able to opt into that because we're also built on EigenLayer. And what you can kind of think about this as is kind of like a two-sided market here. Like based rollups are on the demand side. They require block space, and they want this like done in a prompt manner. And validators have the ability to propose blocks and include these based rollups. So they're like on the supply side. And this pre-confirmation protocol works as like a marketplace in between. Right. So that's everything we're cooking. I hope that didn't overly complicate things.
No, this has been a lot of cool stuff to hear about, learn about. So thank you, Jason, for all of this. And I guess before we end, if there's anything that that we've missed or that you want to mention or anything, about where to learn more, want to give you that last moment before we talk about the POAP. But yeah, anything else you would say or want us to take away from this?
Yeah, so I would just say like stay tuned for a couple updates that are coming. So in version 2 is like the next big upgrade to the LRT, and we're hoping to roll that out by the end of this year. And we'll be releasing more and more information about that, I think over the next week or so. And then on the like based rollup side, we're calling it the Unify ecosystem. So we're really shooting to have a public test net where everyone can go and try out these pre-confirmations and everything around DevCon time. So I'm excited for that. So yeah, please stay tuned.
Awesome. So for anyone anyone watching the call on the YouTube channel right now, if you want the community call POAP, we're using POAP Airship, which means that all you have to do is send 0.001 ETH to poap.estaker.eth, and you can do that on mainnet, Arbitrum, Base, or Optimism. And you have about a day and a half to do that. So before October 4th, 11:59 p.m. Eastern time. Yeah, that's all you need to do. And you'll get the POAP automatically within like 1 or 2 minutes. Great. Thank you guys all for coming. Jason, we really appreciate you coming and explaining and answering all of the questions, all of my dumb questions. This has been really fun.
So yeah, thank you so much for having me. This is fun.